No one truly expected this. The James Webb Space Telescope has discovered 15 strange galaxies. These galaxies appear to exist before the Big Bang. With this discovery, we are now entering an entirely new era. Our cosmology, and even science as a whole, may undergo unprecedented upheaval. Our entire understanding of the origin of the universe and why it exists could be completely overturned. Was traditional astronomy and cosmology wrong? Or is it about to become obsolete? If the Big Bang never happened, could we be observing a parallel universe? Why might our cosmology be wrong? Nobel Prize winner Dr. John C. Mather, the lead project scientist for the Webb Telescope, summarized the current situation at a press conference. In images from James Webb, a series of objects appear so strange and so ancient that they have left scientists baffled. Most of these galaxies are far too large, too complex, and too well organized to be infant galaxies only 300 to 400 million years after the Big Bang. Scientists expected that some star clusters might contain the legendary population 3 stars. These first-generation stars were believed to be extremely massive, extraordinarily bright, but very short-lived. But the shocks kept coming. James Webb discovered another galaxy whose luminosity turned out to be extremely low, not matching the picture of bright supergiant star clusters. Another discovery may involve 6 black holes that were already so massive just 500 million years after the Big Bang that we are forced to ask, where did the matter forming them come from? How did they grow so large so quickly? Previous cosmological models told us that galaxies or black holes would require billions of years to reach the forms James Webb is now showing us. James Webb's observational reach extends back about 13.5 billion years. The telescope does not significantly surpass its predecessor, Hubble, in distance, but Webb can observe space with far greater clarity and detect much more detail. The oldest galaxy discovered by Hubble was GNZ11, which existed about 13.4 billion years ago. On the other hand, James Webb has now discovered dozens of galaxies deep in the universe, some reportedly with astonishing redshifts as high as Z equals 20. These 15 galaxies have now been confirmed, and scientists must now explain their existence. A telescope is like a time machine, capturing light emitted by these galaxies long ago, allowing us to glimpse the early universe. It is as if we are looking back through a tunnel into the past, vividly sensing what the universe was like at the dawn of time. Beyond light signals from billions of years ago, there is another major cosmic indicator, the cosmic microwave background radiation. The CMB is a remnant of the early universe, an almost uniform radiation field that fills the entire cosmos and still carries information from distant events. In 1965, American physicists Arno Penzias and Robert Wilson discovered it by accident. They noticed a strange noise in space, detected by a large radio telescope as faint microwave signals from all directions. Their discovery confirmed the Big Bang theory and the hypothesis that the universe is expanding. The background radiation reflects the state of the universe about 380,000 years after the Big Bang, when the universe slowly began releasing photons and producing light. Therefore, even with background radiation, we cannot fully see back to the Big Bang itself. However, the CMB helps us reconstruct the composition, density, and temperature of the early universe. Scientists can extract thousands of details from tiny fluctuations in cosmic structure and uniformity. These observations have so far supported the standard cosmological model, but now we are forced to question them. Meanwhile, researchers are tracking new mysteries of light, such as luminous galaxies or bright dusk disks around black holes, while also listening to sounds from space with radio telescopes, and attempting to push further back in time using the CMB, searching for clues to what really happened in cosmic history. What many people don't realize is that even before the James Webb era, some ancient galaxies had already been discovered. In 2016, a research team led by Pascal Esch successfully used the Hubble Space Telescope to identify a very ancient galaxy with a redshift of Z equals 11.1. The light from GNZ 11 had traveled for over 13 billion years before reaching Hubble's detectors. This redshift placed GNZ 11 as the most distant known galaxy at the time. GNZ 11 attracted attention not only because of its distance, but also due to its unusual physical properties. Though still young by cosmic standards, it was surprisingly bright and massive. When we observe it, only 400 million years had passed since the Big Bang. This makes GNZ 11 one of the oldest observable galaxies, yet it already displayed extremely rapid formation. Scientists estimate that forming such a complex galaxy would normally take billions of years. Its estimated mass is about 1 billion solar masses, with a star formation rate of about 20 solar masses per year. It also showed unexpectedly rapid evolution and activity. Observing and analyzing GNZ 11 in 2016 was a technical challenge. Its light was extremely faint and highly redshifted, pushing the Hubble telescope to its limits. At the time, researchers were curious about this strange object, but GNZ 11 was considered just one exotic galaxy among many. Now we know that thousands of highly organized and massive galaxies may have already existed in the young universe. James Webb's continuous discoveries are constantly reshaping scientists' understanding, making some older theories appear outdated. Those who once confidently believed they understood the universe's earliest galaxies and stars are now being shown unexpected phenomena. Jade's GSZ 11-0 is a high redshift galaxy discovered by the James Webb Space Telescope on September 29, 2022. The discovery was part of the Jade survey mission. Its name indicates a redshift of 11, meaning it existed about 13.4 billion years ago, roughly 400 million years after the Big Bang. Only James Webb, with its specially designed infrared instruments, could capture the light from such an extremely distant galaxy. Redshift is a phenomenon closely related to cosmic expansion. It occurs when light from stars or galaxies shifts towards longer red wavelengths. This is most likely caused by the expansion of the universe, though it can also result from motion in gravitational fields or Doppler effects from relative motion between source and observer. It was first observed in the early 20th century by astronomer Vesto Slipher and later Edwin Hubble. Hubble discovered that distant galaxies exhibit redshift proportional to their distance from Earth. This observation led to Hubble's law, which describes galaxy motion and age and forms the foundation of the expanding universe theory. Just when researchers thought things couldn't get more confusing, another discovery added to the chaos. Galaxy SPT 11212-58, although not as ancient as GNZ 11 or Jade Z equals 13, is almost a perfect replica of our Milky Way. Spiral galaxies usually take billions of years to form, yet this galaxy was only 2 billion years old when its light was emitted. Its redshift indicates it formed when the universe was slightly older, but it was still in its infancy. Its estimated stellar mass is about 390 billion solar masses, indicating it had already reached a mature state when the universe was just 2 billion years old. This raises uncomfortable questions about how galaxies could develop such mass and structure so quickly after the Big Bang. Given that galaxies require billions of years to evolve, we cannot be observing systems only a few hundred million or 2 billion years old. These galaxies must be far older, implying they may have existed before the Big Bang. For these seemingly young but actually very ancient galaxies, scientists have proposed several possible explanations. First, the universe may be much older than we think. James Webb's discoveries force us to reconsider this. A Canadian-Indian researcher named Rajendra Gupta proposed a theory suggesting that light may slow down due to a tired light effect as it travels through space, which could alter our understanding of cosmic expansion. If this theory is correct, all previous distance measurements of the universe could be wrong. Second, the universe may have no beginning.
Although cosmic expansion and the CMB seem to support the Big Bang, these observations may also be flawed. In quantum mechanics, we find indications that the universe may exist infinitely in time and space. Third, there may have been another beginning. Scientists suspect that beyond the familiar Big Bang model, there may be many other explanations for how the universe formed. One idea is that the universe may have arisen from multiple sources or events, not all occurring at the same time. Thank you for watching Entropy Files.